In this lesson, I just wanted to give you an example of a more complicated problem involving the expansion of a logarithm. So first, let's quickly review our log rules. The first is the product rule, which says that we have log base b of m times n, which equals log base b of m times log base b of n. If you don't like memorizing equations or formulas like this, I like to think of it in terms of our product rule being that if we start off with one log that has multiplication, it becomes two logs with addition. So our product rule starts off with multiplication, but it separates into two logs with addition. Our quotient rule says that we have log base b of m over n, which equals log base b of m minus log base b of n. Again, I like to think of this in terms of a little bit of a hint where we have one log with division will become two logs with subtraction. So your product rule, if you have multiplication, separates into two logs with addition. Quotient rule, if we have two logs with division, if you have one log with division, it becomes two logs with subtraction. Finally, our power rule, if we have log base b of m raised to the p, we can rewrite this as p times log base b of m. Here I like to think of this as if we have an exponent within a log, what we do is the power rule drops that exponent down in front with multiplication. So it just gets dropped down in front. We have no sum rule and no difference rule. If there's a plus or a minus inside of the log, it just stays there. We don't separate it at all. So there's only the product rule, the quotient rule, and the power rule. No other rules. So don't try to do more work. So in this example, we want to expand the logarithm completely. We have log base 6 of the cube root of x plus 1 over 36y to the fourth, all raised to the second power. What I'm going to show you is just some general guidelines that you can use if you're having a hard time trying to figure out what rules to use when. They will work most of the time, so just kind of keep that in mind. There might be some situations where you have to jump around a bit, but these steps are pretty helpful in terms of trying to simplify and expand a logarithm. As Professor Messenger noted in his video, is that expanding logarithms is important once you get to calculus, because we can use that to take our derivatives a little bit more easily. So for our problem here, in order to expand this log, first we want to use the power rule to bring down any exponents or any radicals that are on the outside of the log. So in this case, we have a 2 as an exponent. So that we want to use our power rule in order to bring down. So that means that we would have that this log is equal to 2 log base 6 of everything else. So the cube root of x plus 1 over 36y to the fourth. So all I did was just bring it down in front. There is an implied multiplication. So that is our first step. Our second step would be to separate any division that we might have into two logs with subtraction, which would be using our quotient rule. So our second step, we want to use the quotient rule to separate. That 2 is going to stay in front, okay? So it's important that we understand how we're going to write this, that this becomes equals 2, and I'm going to use a bracket since now we're only talking about expanding this log here. All right, the 2 is already dropped down in front, so everything else is going to go inside the bracket. So our numerator is going to go first. We'd have our first log would be log base 6, the base has to stay there, of our numerator, which is the cube root of x plus 1. And then using our quotient rule becomes minus log base 6 of 36 y to the fourth. So I had square brackets around the log that we separated. And then I also put each numerator and denominator in parentheses as well, because that shows that we're taking log base 6 of the entire cube root of x plus 1 and log base 6 of the entire 36y to the fourth. So the parentheses are important. Our third step is to separate any multiplication that we have using our product rule. So right now we have two separate logs. So our first log is that log base 6 of the cube root of x plus 1. Well, inside that log of the cube root of x plus 1, I don't see any multiplication, so we don't need to use the product rule on that log. The second log that we have is log base 6 of 36 y to the fourth. Well, inside here, we do have multiplication. We have multiplication between the 36 and the y to the fourth. So I do want to separate that using our product rule. So then this is equal to, the 2 stays on the outside, square bracket's still there. Our first log isn't changing. Then we are going to separate the log base 6 of 36 y to the fourth using our product rule. So another important piece here is that since I'm separating that second log, we have the subtraction. I'm going to put another set of parentheses here to illustrate that we're going to be subtracting the entire part. So I have log base 6 of our first piece, which is the 36, plus log base 6 of y to the fourth. So I'm closing the first parenthesis to show that it closes off from the subtraction, and then I'm still going to have that square bracket to show that it's still involved with that 2 out in front. Next, we want to use our power rule again. So we started off using our power rule, but we want to use our power rule again to bring down any remaining exponents or radicals that we might have. So if we look in our first log, we see that we have a cube root of x plus 1. Well, cube root of x plus 1 I can rewrite as x plus 1 to the 1/3, which means that I can use my power rule. So I have 2. When I bring down the 1/3, remember, it has to come right in front of the log. So I think that's always going to drop in front of the L, not going over by the 2. So it's going to be 1/3 log base 6 of x plus 1, so again I'm putting it in parentheses to show that we're taking the log of the entire piece, minus our second log that we have is this log base 6 of 36. I don't have any exponents, so that can just stay the same. And then the last log that we have is this log base 6 of y to the fourth. Again, we can see that we have an exponent of 4, so that 4 is going to be dropped down in front. Again, it's just going to drop down in front of the log that it's attached to. So we're going to have a 4 log base 6 of y. So this is what we have so far. Again, got square bracket to note that we still have that 2 on the outside. Every exponent that we had just got dropped down in front of its associated log. Our last step is to simplify any logs that we might have. So really what that means is that we want to evaluate any logs. So we want to find the logs that might just have numbers. The first log that we have is the log base 6 of x plus 1. Again, we don't have any sum rule. If there's a plus or a minus inside the log, we just leave it alone. So I can't do anything with that one. The next log that I have is this log base 6 of 36. Here is where I can actually evaluate, because remember, in order to find this answer, we would think of this as an exponential function or an exponential equation where we'd have 6 to the x equals 36. And then the question is, 6 to what power gives you 36? And it would just end up being 2. So log base 6 of 36 actually turns into 2. Our last log, that for log base 6 of y, again, we have a y there, so there's nothing to evaluate. Our final answer, one form of our final answer then, would be 2 1/3 log base 6 of x plus 1 minus, so that log base 6 of 36 turned into 2 plus 4 log base 6 of y. And again, just making sure that you have the parentheses in the correct place to show where the expansion came from. So this is one form of the correct answer. Another form of the correct answer would be if we distributed the subtraction inside of our braces. So we would have 2 times 1/3 log base 6 of x plus 1. Distributing that subtraction, we'd have minus 2 minus 4 log base 6 of y. So that's another answer that's equivalent to the original. And then finally, distributing the 2, another possible solution would be 2/3 log base 6 of x plus 1 minus 4 minus 8 log base 6 of y. And in that last form, you don't need any parentheses other than the ones to show what's connected or attached to inside of the logarithm. So it's fine to keep it in that first form, but know that there are equivalent forms in case you happen to be checking your answer somewhere else.